Hello everyone. Today we are going to record another tutorial on the aelf blockchain. This tutorial will cover DeFi application, that is a decentralized application built on the aelf blockchain. This will cover the staking mechanism, and here in this application user will be able to earn rewards based on the amount and the duration of their stake assets. The purpose of this particular staking dApp is to demonstrate the seamless integration of staking mechanism with the aelf blockchain and providing the user with a secure, transparent, and efficient way to grow their holdings. It will also serve as an educational tool for learning about staking and their role in decentralized finance. This tutorial will be covered in 5 steps. The first step will set up the development environment. In the next step, we will develop and deploy the smart contract. And in the fourth and fifth step, we will get the token seed and will interact with the deployed smart contract with the front end application. So let's cover the first step of setting up the development environment. You should have basic knowledge of terminal commands to go through this tutorial. Also, if you haven't installed an IDE, then you can click on this link and install VS Code or any IDE of your choice. Now you need to install some packages. So install .NET 8 SDK by clicking on this link based on your operating system which you are using. In the next step, we are going to install the aelf contract templates. aelf contract templates contain various predefined templates for the ease of the development of smart contracts on their chain. We will copy the next command, that is .NET new install aelf contract templates. We'll paste this command inside our terminal, which will install the aelf contract templates on our system. In the next step, we are going to install the aelf deploy tool. aelf deploy tool is a utility tool for deploying the smart contract on the aelf blockchain. So please remember to export the path when we install the aelf deploy. Copy the command to install the aelf deploy tool and then paste this inside the terminal. In this command, it will ask you to export a path variable. So you need to export that. Next, we are going to install Node.js and Yarn. If you haven't installed Node.js and Yarn for your operating system, you can click on the following links and install it according to your operating system. As it is already installed on my system, I am going to skip this step. The next step will cover the installation of the aelf command. So aelf command is a CLI tool to interact with the aelf blockchain, which enables the task for creating the wallets and managing the transactions. So it might require sudo permissions while installing the aelf command tool. So you need to use sudo with the command and please enter your system password. Once you enter the correct password, then it will start installing the aelf command tool. This will finish our first step of setting up the development environment for this particular dApp, that is a staking dApp. This setup process will be similar for all kind of dApps which you are going to install or which you are going to develop on the aelf blockchain. Also, our earlier tutorials covered .NET 6 version. As we have upgraded to .NET 8 version, so it will support the .NET 8 version as well. Now, in the next step, we are going to develop our smart contract. So now we will start creating a directory first to develop our smart contract. So we'll create a new directory using the mkdir command, and we will then change to that directory and then we'll create a template inside that. So let's first create that inside aelf tutorials. Inside that, I will create a new directory and then I will change to that directory. Then after that, I will create a new aelf template using the .NET aelf command, that is single pool staking. So I will copy the next command and I will paste this command inside terminal, install the template, aelf contract template. To check whether the template was created successfully, you can enter the ls command, which will output the source and the test folders. If you see source and test folders, it means that the installation of the template was successful. Now we are going to add our smart contract code to this template. This template contains the basic logic or the initial structure of the smart contract. But now we are going to write the implementation of the logic for our staking pool smart contract. So now in this step, the smart contract contains the functionalities like depositing the token to the staking pool, withdrawing tokens from the staking pool, and withdrawing tokens from the pool before the lock period ends. So that is called force withdraw. Also, it allows us to get the reward amount for an address from the pool and to fetch all the deposits linked to a user. Also allows us to retrieve the total staked amount in the contract. As you can see, it will contain the list of these functions. Those are deposit, withdraw, force withdraw, get reward, get deposits, and get total staked amount. Now we are going to open the template which we created in the last step in our VS Code. I will open this folder in VS Code. Here, as you can see, there is a source folder and there is a test folder. Inside source folder, there is a protobuf folder. Inside that, there is a contract folder. There is a file that is a .proto file. We need to rename this file from hello world contract.proto to single staking pool .proto. So single pool staking.proto. So we are going to copy this name. You can rename this using the next command as well. I am just going to rename it manually by copying the name from here and going to VS Code and changing the name of the file here. I will rename this file to single pool staking.proto. Now, as we have renamed the file, we are going to define the structure and serialization of the data in the proto file. Function of proto file is to define the structure, or you can say define the methods of our smart contract. So our single pool staking.proto will contain the following proto logic. Copy the next code sample and then we can paste it inside single pool staking.proto. Select the whole code which is pre-existing and then we will paste the new code here, and please don't forget to save the file. So this will create our proto file. So now this proto file contains certain RPC methods. So the first RPC method is the initialize, which helps in initializing the smart contract. And then other methods are deposit, withdraw, force withdraw, get reward, get deposits, and if initialized and get total stake. These are just the definition of the functions and without the implementation. It means proto file contains incomplete implementations of the smart contract methods. This file also contains some messages which are similar to events. One is deposit input, initialize input, withdraw input, transfer input, string list, deposit, and deposit list. These are some of the messages which we are going to use in our smart contract. Now, RPC method defines the callable functions within the contract, allowing the external systems to interact with the contract logic. Messages represent the structured data exchanged between the contract and the external systems. In the next step, we are going to define the contract state. The contract state file in the aelf blockchain holds the variables that stores the contract's data, making sure that this data is saved and accessible whenever the contract needs it. In the next step, we are going to copy the state code sample, and then we are going to go inside the source folder. There is a file called single pool staking state.cs, and we are going to replicate this code in that file. So select this file inside source folder and then select the existing code, delete that, and then paste the new code which contains the states of the single pool staking dApp. Now, in the next step, we are going to implement our smart contract. Implement means we are going to complete all the functions which we have initialized in our proto file. Now, this implementation will be done inside the source folder in single pool staking.cs file, and we need to copy the code sample which is mentioned in the next step. Now, as you can see, there is an initialize function which has implementation for the initialization of the smart contract. Then there is a deposit function which allows users to deposit the tokens in the smart contract as a staked amount. In the next step, you can see that there is a withdraw function which allows users to withdraw the amount once the lock period ends. It allows this to only the authorized users who have staked their amounts, and it also checks whether the lock period has ended or not. In the next function, you can see the function is force withdraw, which allows users to withdraw the staked amount before the lock period ends. So it checks the authorization but doesn't check the lock period condition here. As this is a forced withdrawal, so the users can withdraw the amount before the lock period ends. In the next step, or in the next function, you can see there is a get reward function which allows us to fetch the value of the reward on the staked amount. There is next function that is get deposits, where users can get the list of all the deposits made by a particular address. If initialized is a function which is an internal function which checks whether the smart contract has been initialized or not. Get total staked amount is a total amount which has been staked on the smart contract. It returns the total value of the staked amount. Then calculate reward is an internal function again which calculates the reward for the amount staked. And then there are other helper functions like transfer from contract, get virtual address hash, remove deposit, and get virtual address. So this allows to transfer tokens from the contract to an address. Then there is a get virtual address hash. This function allows to calculate the hash of a particular address. Then there is a remove deposit function which allows to remove the deposit from the smart contract. So we are going to copy this code and we are going to paste this code inside single pool staking.cs inside the source folder. Go to the single pool staking.file and we will select the existing code. We will delete that and we will paste the new code which has the implementation of all the functions which we just discussed. At this point, we have covered the implementation of our staking smart contract. But now here we are dealing with a decentralized finance application which requires some crypto token. So in aelf blockchain, we have a multi-token contract to generate the tokens. So now we are going to create the reference for the multi-token contract in the staking contract. So now staking contract will use the reference of the multi-token contract and then will allow that token to be staked on the staking contract. So now we will create a contract reference, and for that what we need to do is we need to create a new file that is token contract.proto inside a reference folder that is inside protobuf. Go again and we'll go inside the reference folder. We'll create a new file by token contract.proto. Now we need to paste this next code sample that is the proto file for the multi-token contract. So this is the code which contains all the RPC methods which are part of the multi-token contract and which allows token creation and token transfer and like every action related to token on the aelf blockchain is provided by multi-token contract. So now let's copy this file to the token contract.proto and let's save this. So now what we have done is we have created a contract reference for the multi-token contract inside the staking contract. Now as our smart contracts are ready, we need to build our smart contract. First we need to go inside the source folder and then run the .NET build command. So let's copy this command and open the terminal. The terminal should be inside the source folder. We will first change the directory and go inside the source folder, then run .NET build. Now the staking pool smart contract is getting built and now it has built successfully. So now the build was successful for the staking smart contract. There is a bin folder. Inside that you will find a .dll.paste file which will be used later on. So we had a single pool staking smart contract and then after build we got .dll.paste file as an output. Now what we need to do is deploy this smart contract on the aelf blockchain. To deploy this smart contract, we need a wallet. It means we need to create an account which will trigger the action of the deployment of the smart contract. First, we need to create a wallet. So we'll create the wallet using aelf command create. So we'll paste this and it will create a new wallet for us. So now it has returned four things. So one is the private key, one is the public key, then one is the mnemonic and one is the address. Private key and public key are the cryptographic components when you become part of a decentralized network or a blockchain. Mnemonic is a simple form of the private key, or you can say derived form of the private key. Similarly, address is a derived form of the public key. Now, let's save this information in a file by pressing Y. You need to enter a password there. I will confirm the password for this particular account. So what this password does is this password encrypts this private key and the other information inside a file. Now we are simply encrypting a file with a password so that our private key doesn't get to someone who can misuse it. We will be using these passwords and addresses later on, the address of the smart contract as an environment variable, because we want to deploy through terminal. Moving forward, as we have now created a wallet, so now what we need to do is export the wallet password and the wallet address in the terminal so that we can use these values later on in the next command. So let's first set the wallet password, export the wallet password. Now we'll export this wallet password, which is the password of the file we just set. Now set the wallet address. The address is the address we got while running the elf command create. So this is the address I got. So now I will paste this address. I will enter this. So now I have set two environment variables, wallet password and wallet address. So in the next command, I will be using a faucet. So faucet is used to get some test tokens to deploy the smart contract or to interact with the smart contract on the elf blockchain. Now here you can see we are using a wallet address as an environment variable. We'll be using wallet password as well later on. So now let's copy the next command, that is our curl command. So we'll copy this command and now we will paste this command to get some tokens from the faucet for this particular account. Now we have provided the address where we should get the tokens. This command should return success true. It means that we have successfully received the tokens. How can we verify that? We can verify this by checking the balance. The next command will help us in checking the balance. There is a get balance function. Let's copy the next command and paste this command. This command is calling the multi-token contract on the testnet. This is the address of the multi-token contract. Then it is providing the wallet address and password. So for which wallet we are checking the balance and on which network. So this is the URL of our test network, or you can say the elf blockchain's test network. And get balance is the function to fetch the balance of the address which we are passing. So now let's fetch the balance. So now a wallet can have multiple tokens. So for which token we are trying to find the balance, that is elf token, and the symbol for that token is aelf. So we'll enter aelf. Now we need to provide the owner, and owner is this address. So we will provide the address as well. Now, as you can see, there are 100 into 10 to power 8 as a balance which is shown on your screen, which means that you have 100 ELF tokens. Why this value? Because ELF has 8 decimal precision. It means like 100 into 10 to power 8 means 100 ELF tokens. So now one ELF token can be broken down into 10 to 1 by 10 to power 8 pieces. Now, let's move forward. Let's set a contract path. So as we wanted to deploy the smart contract, we have gotten the tokens from the faucet to deploy. But now we need to deploy, right? As we created a .dll.pest file in the previous step while building the smart contract. So let's first copy the contract path for that file. So now we'll export that path using this command. This command will set the path of single pool staking.dll.pest file here. Now we need to deploy. Let's use the deploy command. We'll copy this command and now we will paste this command. If you receive this error that command not found, it means you can uninstall elf deploy tool and then you can install it again. So similar command with uninstall, you can say option. You can use the .NET tool uninstall minus global elf.deploy to uninstall the elf deploy tool. And now to install, you can use the install option. So this will install elf deploy tool again in our terminal. This problem might come for you as well. So you can use this command to reinstall elf deploy tool. And once it is deployed, then you will get an option to export the path. So we need to set this path also. So export this path using this command. And now elf deploy should be reinstalled in our system. So now let's run the elf deploy command again to deploy our smart contract. So this command is simply deploying the contract, this contract path we have given from this wallet where we have provided the wallet address and wallet password to this network. So now let's run this command. So the deployment process will start here and it will generate some proposal IDs in between. Later on, it will deploy the smart contract. try to deploy again, we'll start the process of the deployment of our smart contract. So now it is going to deploy our staking smart contract, the aelf chain. It will take some time to deploy the smart contract. It will generate some proposal IDs to check the status, whether the smart contract has been deployed. And once the deployment is complete, it will return a unique identity of the deployed smart contract that is called as smart contract address. As we can see, deployment process is complete and the deployment was successful. And here the address, this particular address is our smart contract address. This completes the third step of our tutorial, that is deploying our smart contract on the aelf chain. Before moving forward, let's do the next step, that is to export this contract address as well, which we might require in the next step. This is the command to export the contract address, and this is the contract address. We'll copy this and paste it here, and this will set contract address as an environment variable, which we might use in the later stages. So this marks the completion of the deployment. Let's now get the token seed. So how to get the token seed is we need to get this token seed in a wallet, right? So we will be using portkey for that, because we will be interacting with our portkey wallet with on the staking dApp. First click on this link. This will give us an option to get the token seed. Click on this drop down option and select the token seed. Now enter the address. We need to enter our address. We will have an option of main chain, aelf testnet and side chain. We need to select the main chain address, copy this address and get a token seed. Click on get seed button, and in some time it will give us the token seed. If I open this and click here, in some time it should give me a token seed. Make sure that your network should be testnet. You can check your network here. Network should be selected as testnet. It will take some time, and in this NFT section you will receive a seed, as you can see now. So let me just show you in the expanded view. If I go back to my wallet and to the NFT section, here you can see I have received a seed. So now here there is a token symbol. This token symbol will be used when we will be creating our own token. So this token symbol will be used later on. So now I have one token seed. So I can use this to create the token. I will be moving towards the next step, that is to interact with our dApp. In this step, we are going to cover the interaction of the deployed smart contract with a dApp. dApp is, you can say, any front-end application which is connected with the smart contract. Now we are going to first set up the project. So there is a template created, or you can say sample created already for the front-end dApp. So we are going to copy the command to clone this GitHub repo. I will open this repo, that is aelf samples. You can clone this using the git clone command, and then you need to go inside aelf samples staking, then 2D. I will open this folder inside VS Code. So I will open inside aelf tutorial. There is aelf samples, there is staking, and I will open the staking dApp. Now inside that there is a 2D app folder. So first we need to open the terminal, and inside this terminal we need to go inside the 2D app folder. Now as you can see, the structure will look like this, where there will be a public and source folder and other files. So this is a React template you will see here. As you can see the template here as well. Now we are going to run the npm install command. You can provide sudo privileges, as it will create some folders. So run the command sudo npm install to install the required packages and libraries. In the next step, we are going to implement the logic to connect our smart contract with the dApp, or you can say with our front-end application. First, we need to configure our wallet. So it means to connect with the blockchain or to connect with the smart contract, we first need to configure the wallet. What it means is, to wherever we are running the application, let's say we are running the application in the browser. So in the browser, first we need to check whether we have the wallet or not. If we have the wallet, then we will check which provider is providing that wallet. After getting the provider, we will check whether we are connected to the wallet. Let's first configure the wallet. We will go inside source hooks and use smartcontract.ts file, and there we will find the step A, that is function to fetch a smart contract based on the chain symbol and the contract address. The function is fetch contract. Let's copy this code sample to implement the fetch contract function. We'll have to find step inside the hooks folder, that is use smart contract.ts. So we go inside source, then there is a hooks folder and there is use smart contract.ts file. As we can see, the step is on line number 12. So we are going to select the existing implementation of the fetch contract function, and we will paste the implementation which we just copied from the port. Save this file. It will implement the fetch contract function. Now let's go to the next steps. Now this particular fetch contract function fetches a smart contract based on the given chains. So there are two chains on the testnet, that is the aelf main chain and the aelf side chain. So aelf main chain has this symbol and aelf side chain has this symbol. Then checks the provider, fetch the chain, and then get the contract or retrieve the smart contract instance from the chain. Now to initialize and fetch the smart contract, find the step B, that is for the effect hook to initialize and fetch the smart contract when the provider changes. Let's say if there are multiple providers, so if a provider changes, then this hook will operate. So now we are going to fetch this. So we copy this code sample and we will find step B inside the same file. So there is a step B, it is a use effect hook. So we are going to select that and we are going to complete the implementation of that use effect hook. Now this is the implementation of the hook to fetch the smart contract when the provider changes. In the next step, what we are going to do is we are going to initialize, or you can say we are going to write the function for the state contract we have already initialized. What this hook did in the last step is check the provider. If no provider is available, it will tell us that no provider is available. Then it fetches the contract if the provider is available for the main chain and the side chain, and then fetches the main chain testnet contract and sets the state, and same for the side chain as well. Now we will locate another file, that is use staking contract.ts inside same hooks folder, and we will find step C, that is function to fetch a smart contract based on the chain symbol and the contract address. So here we are fetching the smart contract again. Let's copy this code sample and then go to use staking contract. So here we are going to fetch the staking contract. There we have two contracts. So one is staking, one is token. So we need to fetch multiple contracts. So here we are going to fetch the staking contract. So we have written the fetch contract function here. So what this function does, it checks for the chain symbol, and then based on the chain symbol, it gets the contract instance by providing contract address, and then it returns the contract instance. Then in the next step, or before going to next step, this fetch contract again does the same thing which the other fetch contract does. It checks for the provider that fetches the chain and then get the contract instance from the chain. Now in the next step, we will initialize this smart contract. So now we will again implement the hook and will find for the step D in the same file. Copy this code and again go to the same file, and there is a step D to select that hook, and we need to paste the implementation. Now we have implemented another hook. So this hook will again fetch the smart contract when the provider changes. By following the steps, we have configured the port key provider to connect the user's wallet to the dApp. And now it will interact with both the multi-token contract and the staking smart contract. As I said, there are two contracts, so we need to get the instances of both. Now we need to interact the fungible token and the staking functionality. Fungible token interaction will happen from the token contract, and the staking contract will be responsible for staking the tokens, withdrawing the tokens. So these functions will be used there, and create token transfer tokens will be used from multiple contract. Now let's configure the connect wallet functionalities. Now we have configured the provider. Now we need to check whether the wallet is connected once the provider is available. So now we need to go inside source component layout header. There is an index file. This index file is the header of our staking dApp. So it allows the users to connect their portkey wallet with the staking dApp. And before user can interact with the smart contract, we need to connect the wallet. Now we need to find the command, that is step E, and to copy this code, and we need to go inside this file, that is inside source component layout and header. So that is source component, then layout, then there is a header index, and step E is here. To find this step E, and there is a connect wallet function. We need to paste this function here. So now we will paste this to connect. In the next step, we are going to configure the create token. To create the token before using their token for the staking purposes. Connect function fetches the wallet accounts using the provider which we fetched in the last step, is the wallet address and loads the accounts. Now let's configure the create token form. So now go to source component create token model, and there is an index file there. So we will create a fungible token, and we will create a pop-up model to enter the information. So which might require token name, token symbol, and token supply. So token name is already predefined here. So we will copy the implementation of this form, and that will be found inside the create token modal. We will go to source component create token modal. So this is the modal, and there is an index file, and we need to find the step F. So now this is the step F, which is the form to create the token. So paste the implementation here. I will save this file. In the next step, so this function, as the name suggests, creates a form which takes the token name, symbol, and total supply as a. Now we will the cross-chain contract. So now we need to find this step G. So this cross-chain contract we are fetching. We are fetching the contract name, cross-chain contract name, and then getting the chain status, and then after that getting the genesis contract address and zero contract address. This is required when we create the token. We'll go to the get cross chain contract step, that is step 8 inside the same file, and complete this implementation in step G for the get cross chain contract function. Complete this implementation. In the next step, we are going to get the parent chain height. As I said in the last step, we got the chain status. It gets the chain status from the chain status function, which is there in aelf, and then it gets the genesis contract address from the chain status, and then it fetches the zero contract using the genesis contract address and the wallet, and then it fetches the cross chain contract address by calling the get contract address by name method from the zero contract. Now we'll write the get the parent chain height function. So now to find the step H, that is the parent chain height. So we'll copy the code in the next step, and then we'll find the step H in the same file, that is get parent chain heights, and we'll paste it here, which completes the implementation of get parent chain height. Now this function calls the smart contract method. So it interacts with the sidechain smart contract method to fetch the current height of the parent blockchain, and then it returns the parent chain's height. Now we'll fetch the Merkle path by transaction ID. So we will complete the step I. So we'll the implementation from here. This code gets the Merkle path of a transaction ID. So now copy this, and it fetches the Merkle path and parses the response and returns a Merkle path. So now we'll copy this, and we will complete the step I to get the Merkle path. So we'll save this, and now in the next step, we get the token contract. So now this step J, that is getting the token contract. First, we will initialize the token contract name, that is using aelf.contract names.token, and then we will get the chain status, then the genesis contract address, and again the zero contract, and then using that we will get the token contract address. using the function get contract address by name dot call. So what this function does is gets the chain status, then it's the Genesis contract address, then it fetches the zero contract and fetches the token contract address as well. So it copy the implementation of get token contract, and we will go to step J to complete the implementation of get token contract, and we'll save this. Now we create a fungible token on the main chain. So that is a step K to create the fungible token on the main chain. So we'll go to step K, and this is the implementation to create the token on the main chain. So it prepares the token parameters like who is the issuer, what is the supply symbol, and the name, whether it is burnable or not, and all these values it take. It calls the method in the main chain smart contract to create the token, and then it logs and gives us the notification using the toast, checks for error as well. So this is the implementation. Now we will copy this and we will paste this inside the same file for the step K to get the token contract on the main chain, or you can say the creating the token on the main chain. Now here is the symbol, there is a node. We need to get this symbol from our hotkey wallet, which we go through the aelf faucet where we got a token seed. We are going to write a function to validate the token info. Now this is a step L. We will validate the main chain token creates transaction. So now what we are going to do is we are going to check the step L inside the same token model.index file. So we will copy the implementation of the validate token function. So what it does is it validates the information and then it sends a notification. It validates the symbol, the name, the supply, issuer, and all these information, and then gets those information from the blockchain, and then it validates it based on the height and other parameters, checks like other parameters like Merkle path and other like height, parent height, and all those parameters. It checks whether the token info is correct or not. So it is simply validating whether the token exists on chain. In this function, we prepare the validation input, and we get the token contract. Then we sign and send the transaction to validate the token info. We check for the transaction result and we fetches the Merkle path. So we'll copy the implementation of validating the token info code and we'll paste it inside the step L. So we'll go to step L. So this is our step L to validate the token info, and we'll paste it here. Now, in the next step, what we are going to do is we are going to create the fungible token on the side chain. We have created the token on the main chain first, and we now to create that similar token on the side chain as well. To find step M, that is to create a token on the side chain. So what this function does is it takes some values from the parent chain, like parent chain height and main chain ID, and it calls a method that is to cross chain token, and it calls this function cross chain token to create the token on the side chain from the main chain. Main chain token has been created, and now we are creating a token from the main chain to the side chain. So now we prepare the parameters and then we call the smart contract method that is a cross chain token. So complete this implementation. We'll go to step M and finish the implementation of this step. And now we'll go to step N, that is to issue the created token sidechain. The flow is like this. On the aelf blockchain, we need to first create the token on the main chain. Then we create that same token on the side chain. And then we issue that token on the side chain to a particular address. So now this is the implementation to issue the token. So it will take some inputs like symbol and amount, memo is the message, and to what wallet address we are issuing. It will call the issue method inside the sidechain smart contract. Then it will give us some notification that whether it was issued successfully or not. To complete the implementation, copy the implementation of issue token on sidechain. We'll go to step N and we will paste this code here, and we will complete the implementation of issuing the token on the sidechain. Now, in the next step, transfer this token to the staking contract. We need to transfer the token to the staking contract because to give some rewards to the users. The staking contract will behave like a pool where it will be staking amount and will give the reward from the same smart contract. So now we'll write the transfer token to staking contract. The tokens were issued in the last step to an address, and from that address we will transfer these tokens to the staking contract address. So now, as you can see, we are using the transfer function and transfer NFT input, and we are transferring the symbol amount and all this information, and then we call the sidechain smart contracts transfer method. So now we are going to implement this and it will give us a notification whether the token transfer happened successfully. So we prepare the input and then call the smart contract method. So these are step O. So we'll find step O, transfer token to the stake contract. Paste it here and we will go to the next step, that is step P, that is to initialize the staking contract. Now what we have done is we have created a token that is a fungible token on the main chain. Then created a similar token because we got the symbol of that token, and then created that token on the side chain, and then we issued that token to an address and then transferred the token to the staking contract. Now we are going to interact with the other smart contract, that is the staking contract. So we were interacting with multi-token contract. Now interact with the staking contract. So we'll go to step P to initialize the staking contract. So again, go to the same file and this will call the initialize function inside our staking smart contract. If you remember, when we were doing implementation, there was an initialize function and then it will the notification whether the staking contract is initialized successfully. We'll copy this implementation. So now go to step P to initialize the staking smart contract and we will save this file. Now go to step Q, that is to configure the submit. So now on submitting, this form will create the token on the chain and the token on the side chain. So this is the form which handles all those operations which we did in the previous steps. So this is the form. So we are going to copy the implementation of the form, that is the on submit form, which will handle the sum of the create token function. So now what it does is it creates the token on the main chain, then validates whether the token was successfully, then creates that similar token on the side chain and then issue that token on the side chain and transfer the reward amount to the staking contract as explained earlier, and then it initialize the staking smart contract. So now we will copy the implementation of this on submit function. We'll go to step Q to implement this on submit function. We'll paste this and we'll save this file. Now we need to fetch the token as we have created a token. So now we'll go to the source pages home folder. There is an index file and there is a step R return to fetch the token data. So this is simply to fetch the token data, the balance, the token for symbol on the side chain. The chain ID is this one. So we are fetching on the side chain here. We are providing the wallet address and then we are calling the PI here, as you can see. Then we get the token data in the response, and then if the token data is not empty, we set the token info based on the response we got. So we fetch the token balance, then we filter the token details. So this is the implementation of the function that is fetch token data, that is step R, which is inside pages and home folder. There is an index file. So there is a pages folder, there is an index file, and to find step R, so we'll find step R first to fetch the token info. We need to find the step R, that is to fetch the fungible token data. So there is a fetch token data function. So now we complete this function. So we will copy the code for the fetching the token data function. So this is the fetch token data, that is a step R. Copy this implementation and we'll paste this implementation here. Now in the next step, what we are going to do is we are going to deposit the stake amount on the staking contract. So now we are going to call the function to deposit our amount, our token amount to stake. This will simply stake our token amount. So what it will do is from our wallet address, it will transfer the tokens to the staking smart contract address so that they are staked there so that we can earn rewards once the lock period ends. So the lock period is defined also. Now we go to step S, it is transfer token to staking contract. So this function, what it does is it calls the transfer function of the token contract because we are transferring the tokens here, takes the symbol amount and to which address we are sending. So we are sending to the staking smart contract and then it gives us the notification whether the tokens were deposited successfully or not. So we copy the implementation of this step. This is step S, that is the function to transfer token to the staking contract. So we'll find step S here in this file and complete the implementation of transfer token to the staking contract. Now, as we have transferred the tokens, we will handle the staking function. We will write the function to handle the staking of the tokens. That is a step T to handle the staking has certain params, that is like staking ID, deposit params like token symbol, amount, and lock time. So time here you can see is 300 seconds. So that is 5 minutes. It means after 5 minutes, your rewards will be generated, or you can say you will get an extra reward. So this is the lock time. And then we are calling the deposit function of the staking contract here. And once it is done, you will get a notification that tokens are staked successfully for us. And if there is an error, it will return an error as well. So we need to find the step T, that is handle staking, and we will implement this function. So now we'll save this. The next step, what we are going to do is we are going to fetch the deposited or staked token. So let's say I have deposited multiple times. So I want to fetch the data about my deposited tokens. So now I will call the staking contract function, that is get deposits, which will fetch all the deposits for my wallet address, or you can say the current wallet address which is connected. So that if the data is there, it will set some states and it will catch the errors if there are some errors. So we need to go to step U inside the same file and we are going to complete the implementation of fetching the deposit data. So now we'll save this and now we'll go to next step, that is to fetch the total staked amount. That is step B. So we'll find the function fetch total staked amount inside that. So it is going to call the staking contract again. And there's a function that is get total staked amount on the smart contract. So how much amount has been staked by multiple users on the smart contract? We're going to fetch that. So we'll copy the implementation of fetch total staked amount and we'll go to step B and we will save this. We'll paste this and save this. This is the implementation of fetching the total staked amount. Now, in the next step, we're going to withdraw the staked amount. So now we are going to write the function to withdraw, like whatever we have deposited. So in this, we are going to call the staking contract and we'll call the function that is withdraw function. And this can be called once the lock period ends, because we have seen that our smart contract had a condition that once the lock period ends, then only the withdraw function will call. So this withdraw function can be called once the lock period ends. And then once the withdraw is done successfully, it will give us the notification. What we are going to do is we are going to implement this function, that is withdraw stake, as a step W of our process. So now we'll complete the implementation of withdraw stake function. Also, we might want to withdraw our stake in an emergency, right? We need our funds right away. In that case, we can forfeit our reward. We can withdraw before the lock period ends. And this is the implementation of withdrawing in the emergency. So we'll call the force withdraw function, that will be part of the staking contract. And once it happens successfully, it will show us the notification that the tokens have been withdrawn successfully, but without the rewards. Withdraw function withdraw the tokens with the rewards and force withdraw throw the tokens without the reward. So we'll copy implementation and we'll go to step X, that is emergency withdrawal stake, and we will pick this here, and this completes the implementation of our emergency withdrawal function. Now we need to set the staking contract address. So in the step 3, when we deployed our smart contract, what we got our staking contract address. So we need to go to step Y inside our library folder inside source. There is a file that is utils, and we need to change our deployed staking contract address. So now here in this step Y, we need to paste the address. We will go to get the address, that is the smart contract address which we got after the deployment. Here is the address. I'll copy this address and I'll go inside library. There is a utils file, and here paste our smart contract address. This is the address which I got after the deployment of the staking contract. I will save this file. Now I have completed the implementation of step 5. The next step is to run the application. Now, as we have completed the implementation of our front-end components, let's run our application. To run the application, we need to run this npm run dev command. Let's run this command inside the terminal. It will run the application in localhost at 5173 port on this URL. And now I can see that the dApp is running. I can successfully connect using this port key wallet address, which is showing for me. So it is showing that it is already connected for me. You can disconnect as well. If it shows connect wallet button, then you can connect the port key wallet. Just need to approve on the port key. Now let's create the token. To create the token, first what we need to do is get the token symbol. If you remember step 4, token seed generation, we created a token seed, right? So here is the token symbol. Let's just copy this token symbol. Now to create the token, click on this button, and we have reserved the name $token. You can use the symbol which we just copied from the seed. And now let's use this as a supply. Now this will be our total supply of the token. Now click on create token button. Now it is showing that creating the token on main chain. So now I need to sign this transaction. So this will create the token on the main chain first. So now token has been created successfully on the main chain. So as we have seen in the process, first the token is created on the main chain, then it gets verified that the token has already created or not. So it means it validates the token creation transaction on the main chain first. Now as the validation has been completed on main chain, so now it is asking me to create the token on the side chain. So this is the process. It validated the information. Now once the validation completes on the main chain, then it starts creating token on the side chain. Once the token is created on the side chain, then it asks to issue the token on the side chain to an address. So now we will issue the token by signing this transaction. So now we are issuing the token to the portkey wallet. We need to transfer some tokens to the staking contract because we need to provide some rewards to the users who are going to stake their tokens. So we are simply transferring the reward amount. Let's sign this transaction as well. So this will transfer tokens, new created tokens, and to the staking contract. Now in this step, we are initializing the staking smart contract. So we had token contract, then we had staking smart contract, which had a function initialize. And as I explained while developing the smart contract, that we need to initialize the smart contract before using its other functions. So now let's sign this transaction to initialize the staking dApp smart contract. So now it means the staking contract has also been initialized as well. As the token balance you can see is this much, which was the total supply. So now I can stake the amount, total amount. Let's say if I want to stake 100 tokens out of it, or maybe let's say for example, I want to stake 5,000 tokens out of it. So now it is saying that in 5 minutes, I will get 1.1 multiplier of whatever I stake. So it means the reward is 10% in 5 minutes. So this is for the demonstration purpose. Every staking application which you will see in the market might have different multipliers or different reward mechanisms. So now let's take 5,000 tokens. So this will again initiate a transaction of 5,000 tokens. And now let's sign this transaction. So this is calling the deposit function. So this is simply transferring the tokens to the smart contract. And now I need to sign this transaction. The lock period is the 300 seconds, so that is 5 minutes. Now I can see that the stake token amount 5,000, which I just staked, has been staked on the smart contract. Now I have staked the amount already, as it is saying that the remaining time to withdraw is 4 minutes 36 seconds at this moment. I need to wait for 5 minutes to get this multiplier, and I have an option to withdraw by doing the emergency withdraw as well. In that case, I will only get the 5,000 tokens. Now let's start testing the functionality of emergency withdraw before the time period, or you can say the lock period, ends for a particular stake amount. So now let's say I need to withdraw in an emergency. So I'll click on this button to emergency withdraw, and then I will sign this transaction. And once this transaction finishes, then the withdrawal will happen successfully and it will be added to my account. So now it will say that the total staked amount is now 5,000 pounds. Total stake tokens means like total staked on the smart contract till date. So now as you can see, the balance has also changed. Now let's wait for this lock period to end, and then we will test the withdraw functionality, and then the whole staking dApp application will complete. Till now we have tested the functionality of creating the token, then staking that token on the staking smart contract, then doing the emergency withdraw of our tokens in case the lock period hasn't ended yet. And now we are going to test the withdraw functionality. As we can see, the lock period has ended. Now this entry has come under the withdrawable token section. So now we can test withdrawing this token. And now let's sign this transaction to withdraw these tokens. And now the withdrawal is also successful. Now for total staked amount, for me is 0, and total staked amount on the contract is 1,000. So now it will change the balance in some time for you. It means it will deposit the reward along with the tokens here. So we have tested the functionality. Here you can see the balance has changed, and I have gotten 1.1 multiplier, that is 10% extra of the staked amount. So it means now I have tested the withdrawal functionality. If you have some problem and if you want to follow the process step by step, you can download Portkey using this link by using the Chrome extension, and you can set up Portkey using these instructions. And later on, you can follow these instructions to run the staking dApp on your system. And as now we have completed all the functionality of the staking dApp, so we have concluded this tutorial with the functionalities like creating the token, then depositing that token for the stake amount, withdrawing that token after the lock period ends and before the lock period ends. Before the lock period ends was called as emergency withdrawal. So now as we complete, I congratulate all the learners who have completed this step of building the staking dApp. Congratulations again on setting up all the development environments, then installing all the commands and prerequisites which were required, getting the token seed, and then configuring the front end for the staking dApp. Thank you again. If you want to try advanced things, then you can replicate your logic for multiple pools and redefine the smart contract with other logic. You can enhance the staking protocol. You can test our cross-chain interoperability functionality as well. Keep experimenting and innovating with the aelf blockchain. Thank you again for tuning in for this tutorial. Thank you.